Welcome to Los Angeles Data Platform. Good time of the day, everyone, whenever you are. And by the way, please drop your city and country into the chat so we know which communities we are serving. Welcome to Los Angeles Data Platform User Group. Thank you for joining us today. My name is Steve, and I'll be host and moderator of this virtual meeting. If you are new to us and you would like to keep in touch with us and see all the meetings, you can either do it through Eventbrite or you can do it Meetup. If you want to send us an email, there is an email there as well. And of course, if you register on Eventbrite or on Meetup, you'll get notified on upcoming meetings as well. If you are, again, attending us first time or any other time, if you want to follow us on social media, here's all the links that you can basically follow us on social media. Please feel free to join us on our mailing list. This way you will receive notifications of upcoming meetings, notifications when the recording is published. Also, we have a weekly newsletter that sharing links with interesting ideas and interesting scripts. And this event is sponsored by Data-Driven Technologies and Microsoft and SolarWinds. And I think I don't need to mention what Microsoft does. Maybe I can mention what SolarWinds does. They acquired SQL Sentry, so they essentially creating monitoring tools for SQL Server as well as other platforms, other solutions. For the Data-Driven Technologies, it's a nonprofit that funds this meeting and also funds the SQL Server in Los Angeles event as well. At the end of this meeting, we'll be raffling a custom t-shirt. So you can scan that QR code or you can click on the link, that tiny URL, and it will take you to a form where you can fill out the information. And at the meeting, I'm going to be raffling t-shirt from that list. And of course, you need to be present. We can only ship to US, and the color that you see on the screen might be not available. Other than that, it's a custom t-shirt. During the interpretation, please feel free to drop questions into chat, or you can unmute yourself and ask questions. And without further ado, let's move to the rock star of today's online meeting. Rob, please take it away and introduce yourself.
Thank you, Steve. Thank you very much, everyone, for attending, and thank you for inviting me to speak for your group this month. So my name is Rob Volk. As you can see, wow, that picture. Okay, I have another picture on my other slides. And,
this is LinkedIn.
This is LinkedIn? Yeah, I haven't updated LinkedIn in a while. I'm like 2 jobs behind on LinkedIn. So, but that's fine. I guess I can switch over to, I'll share my screen. And I want the desktop, not the, okay. Give me 1 second, let me go back to, okay. So you can see the slide now, the title slide?
Yep.
All right, and give me a second, you can now see Management Studio?
Yes, Management Studio.
Okay, great, thank you. All right, just double check that. All right, so once again, this session is Tame Your Unruly Data with Constraints. And my name is Rob Volk, and my bio information is here. That's the picture I wish I could use, but unfortunately it's too small, and they don't let me upload it anymore. So I have been a SQL Server user for almost 25 years now, and have been mostly a database administrator for about the last 15 years. It's a little more than 15 years now, probably around 2002, 2003. Let's see. I am one of the organizers for the Atlanta SQL Saturday and Data Saturday events. We just had a Data Saturday event on October 1st, which was our first in-person event in about 3 years, and that went very well. I'm also one of the moderators on SQLteam.com. If you have database questions, if you find some other forum sites a little too intimidating, SQLteam.com is pretty welcoming. and we answer a lot of questions. I am on Twitter. My Twitter handle is SQL_R. If you have any questions I don't answer here, you can email me at SQL_R@outlook.com. And I'm in the Atlanta area. So for about, 22 years now? 2001, 21 years. Okay. So this session is, okay. Thought I had another slide in there. We're going to talk about constraints as a database feature in SQL Server. I'll be talking about multiple different levels, some of them theoretical, some of them practical. I'll have some demos. I am presenting a slightly modified version of this presentation. As you might have guessed from the other slides, I'll be presenting this at Past Summit in Seattle in about a little over 2 weeks, 3 weeks, I think. If you see it, you don't have to see it there. It'll probably be different from what I'm presenting tonight. There'll just be different demos and probably some tweaks to some slides. But what I wanted to discuss and point out for those that are either new to database design or new to SQL Server is the ability of using constraints within your database to make things better in a lot of different ways, a lot of different dimensions, by maintaining logic or rules or things that can improve your data integrity directly within the database. Using this as a adjunct and a foundation for good database design, and just to make databases better. When I first did this presentation, it was quite literally me ranting about this job I'd had just before I started presenting, where they didn't have any constraints anywhere, and I spent months of my life cleaning up bad data. And I just felt like people needed to know about this. So again, I'll be modifying this a little bit from that original rant because it's so old and I don't think anyone wants to hear me ranting. I do have some things I can talk about, basically opinions and experiences that I've had. So I'll get to that. To start with, I do want to define a few things, some of the theory behind what constraints are. There's 3 general groups of constraints in a relational database system. The first being domain constraints. These are basically your data types and what we would refer to as a column. Data type and a column. So if I have a first name, that would be character data. If I have a date of birth, that would be properly typed as a date type, where the database engine has its own internal logic to process a date correctly. We have numbers for things like how I'm ordering something from AdventureWorks. How many of those things am I buying? What do they cost? Is there a discount? That kind of thing. So each of those columns would have different data types depending on what's appropriate for the type of data we're storing. A quantity would be an integer because I can't buy half of a bicycle. A discount would have some monetary value to it, that kind of thing. From domains, we create an entity where we have multiple domains, like a first name, a last name, an age, a date of birth, and some other information we might have about a person or an employee or something like that. And the combination of those different domains would form what we'd call an entity in relational theory. And this is slightly different from what the terms you might use in a database product. A domain would be basically a column, an entity would be a row. And then we can apply constraints not just on individual domains through the types and check constraints and other things. We can also apply a constraint across the entity. Like, is it unique? Which domains, which attributes make that entity unique? Or not? Do we have any particular conditions that we want to enforce, not just on one particular column, but across combinations of columns? We might do that with a check constraint, and I'll have some demonstrations on those. And then lastly, the relational database theory and practice is that we will reduce certain entities down to what's the minimum that's required for that one particular entity. But when I want to have a relationship between two things, typically you'd have a customer table and then the customer has orders. You'd have some kind of customer ID that's associated with their orders so that you can keep track of which customers ordered what merchandise. And then the order itself would say, I'm going to have, say, a line item of some kind. In AdventureWorks, it's called sales order detail. That would actually tell you, here's an order that they placed, and then here are the items that they've actually purchased for this order. So we'd have a customer ID to the sales order header, and then a sales order ID that goes down to the sales order detail. And then that way I don't have to keep copying the entire customer information for every single line item on every single invoice or order that they place. We're trying to reduce the redundancy there and minimize how much data we have to keep between different relational data tables. And that's the gist of it. And also, feel free to interrupt. I can't see the chat on the window, so let Steve know or someone else know, and they can ask me to pause, and I'll be happy to answer questions as I go.
Sure, will do.
All right. As I mentioned, we had three general types of constraints. And the first for the domain constraints is, again, the kinds of things that we would apply to a single column in a table. And the first thing, it's not considered a constraint, but I do think it's fundamental to making constraints work correctly, which is to get the correct data type for the data that you're storing. If I was seeing you folks in person, I would ask how many of you have a date column somewhere that's actually defined as character data. You probably all have had that now, or you've had it in the past, and you have to deal with invalid dates, misspelled months, things like that. And that's one of the things that I'll have a little more follow up with this as to the kinds of things that you need to decide when you start designing your tables and your databases. And I'll go into a few more examples about why it's important to be clear about when something is something really a number. For instance, a social security number, it's not actually a number. A zip code is not actually a number. They're just numeric codes. And I'll go into some of the, why such things are not actually numbers. So in addition to getting data types correctly, you want to address whether certain data has to be available, or if it's possible that you may not know what that value is, and that would determine whether you declare that particular column as nullable or not nullable. Certain other features of the database, for instance, a primary key, you would not be able to put a primary key on a nullable column. The idea is that I need to make sure that I have some way of identifying this data. That would be an entity constraint to say this is unique. There's only, say, one John Smith in my database, in my table. But I have to make sure that the name is there. It has to say John Smith for both first name and last name. If I wasn't sure that there's some missing information, like Madonna, I might want to put Madonna in my database and she doesn't use her last name, I wouldn't be able to put a null for last name and have it as part of a primary key. I would be able to put a unique constraint on it so that there's only one Madonna with no last name. And I'll talk about that a little bit more as well. Now, it may also be that it's not enough to, say, have a number of a particular data type. For instance, an order quantity. I might declare that as an integer, but I can't order something, I can't put in a negative quantity, because that would mean instead of me buying something from the store would actually be taking, like if I bought a bicycle from AdventureWorks and I put in a negative quantity, they would be taking the bicycle back away from me and so on. So you would have to put in some kind of constraint to say, hey, only positive integers are available or should be in this column here. And that's something that's sometimes overlooked. And again, I'll have some specific examples of how you can enhance that. Some of them will be actually based on AdventureWorks. The default constraint is if you do have instances where there's certain columns that you may or may not know what the value is at the time you insert a row, you can have a default value applied in case you don't specify another value for that particular column. One case where most people have a default is if there's say a created date. And this is just some column you have off to the side to say, basically, this is when the row was inserted into the table. And then the default value would be the current date and time. But it's something to have. It's nice to have for ensuring that you've got enough information to find, hey, what did we order in the month of January or August or something like that. You'd have some date supplied and applied via the default constraint on that column. The switch here. So any questions on any of those? Is everyone still awake?
Would you consider foreign key a constraint as well?
It is. It's on the next slide.
Okay.
Yeah.
Okay, got it. Ahead of time. Okay.
Yeah. Well, it's just that, yeah, the order, normally this is how people approach this, is they start with domain constraints because you kind of need a column before you have a row, before you can start defining a row. And then you need the entities in the table set before you can start setting up a relation between them. So logically, this sequence makes a little more sense. So yeah, I'll get there, and I do have some demos of foreign keys and some other stuff about that. And then once we've determined, okay, I've got some columns and I've got a couple of things I want to put together in the table and store rows in it, I need to be able to make sure I can process these rows correctly and that the rows themselves make sense. Again, primary key and unique constraints. This is to prevent duplicates from being in a system to where I might be, say for instance, two people named John Smith. I need to know which John Smith ordered what. These two John Smiths might live at a different address. So I would need to make sure that I get the correct address associated with the correct John Smith. From a more realistic perspective, I might need something like a social security number, some other item associated with those two gentlemen that does uniquely identify them besides, say, their fingerprints or their DNA, something that I wouldn't necessarily have access to. In the case where I couldn't make a unique constraint or a primary key on John Smith as their name, I might have to create something like a surrogate key. This would be like a system-generated ID of some kind, or a unique identifier, a new ID, a GUID that I generate. And the fact that their names might be the same, they're still two different people. I still need to make sure that they're unique because I don't want to keep flooding them with, I don't want to accidentally duplicate the exact same person. Because now I won't be able to ensure that I'm identifying any other activity that's associated with them. Say, for instance, a criminal record, mistaken identity. That's a problem, and that does happen. And it's not necessarily the fault of a database system, but if you don't get the uniqueness correct, it could be. And I'm sure no one would want to be associated with a criminal who just happens to have the same name as they do. I know there's been stories about that in the last year where the names were mixed up and they didn't have another way of identifying the people correctly. And beyond the uniqueness, again, there's also a check constraint, but it's not just checking the validity of a single column, it's also checking the validity of a combination of columns. I have a reference later where the National Health Service in the UK were diagnosing males as being pregnant because they didn't have a certain kind of constraint or a check in somewhere in their process to ensure that what turned out to be a diagnostic code, someone would fat finger a diagnostic code and suddenly these guys would become pregnant, which is not how it works in real life. It's a lot easier than how it works in real life. And it's humorous up to a point, except that some of them were being prescribed drugs for pregnant women that probably would have had not so great side effects. There was another instance in the same NHS of I think it was teenagers or young kids and teenagers being diagnosed with, say, like arthritis or other geriatric diseases. And again, they were offered treatment or prescriptions for drugs that could possibly not be safe for them to get. And it was simply a 1-digit or 1-character typo in a diagnostic code. So something like that, where I'd have to make sure, hey, make sure that this diagnostic code or whatever this condition is only applicable to the correct people. So a check constraint might be, hey, gender is not equal to male, or gender equal female, and pregnancy equals yes, something like that. Or find a way of expressing that logic so that you can't accidentally make a guy pregnant, or someone that just can't be pregnant for some other reason, say, age or something like that. So that's where that may not be something that you would typically think about. And I know I have some more examples taken from AdventureWorks on certain other things. And as mentioned about foreign keys, this is where we start to take data in one table and link it to data in another table. So like my name with my Netflix queue. So they'll have a list of subscribers and they'll have a list of shows. They'll have then a list of which subscribers watched which shows. They'll probably have a little bit more information, like when did I watch, like when did I last binge, like say Stranger Things or something like that. Because they don't necessarily want to copy all of my information with my name, my address, my credit card info with every single time that I watched a particular show or a particular episode. They just want to carry the minimum amount. So they have, hey, here's a subscriber ID, and we have a list of subscribers in another table. Here's the show ID or the episode ID, and there's a list of episodes. And then here's when they watched them. It's just some kind of timestamp that tells them when they watched it. So again, it's minimizing the redundant information that we have to maintain in order to log, say, like an event of some kind or any other kind of data that does have some relationship between them. So this is done with a foreign key constraint, where you would have what's typically referred to as a parent table. The correct term is the referenced table. This is the table you're referencing to find a valid value for, say, a subscriber ID. So I would look in the subscribers table. There would be a unique constraint of some kind on that subscriber ID. And then I would tell my my viewings table to reference that subscriber ID. And then similarly have a unique constraint on an episode table and the episode ID and so on. And I say it's sort of like a background check on your data. I have another example in a later slide. I think it's about a mortgage table, and it's something that's it's probably going to sound a lot more common sense when you think about what you need to ensure the data that has to be there for this say mortgage or this other thing to be valid, and how the two things relate to each other. Let me see if that's next. Okay. So I guess I'll have to come back to that, because I do want to go into, no, hold on. Nope. I'll continue with the sequence of slides here. So that is the theory behind what we want to do with constraints and what purposes they serve, is to maintain integrity and consistency within a particular attribute in a table, a particular column, and then integrity across all the entities in a particular table, and then maintain some kind of integrity between multiple tables that have some relationships between them. So now we do want to discuss, how do I find out about this stuff? For those of you that have ever started a new job and you have to learn the data model, and of course, none of this is written down anywhere. And what you probably do is just point some kind of diagramming tool at the database and hope that they put in things like foreign keys and all that. So it'll draw the pretty lines between the tables and all that. And how those tables typically work is that there are system views and some other documentation structures in most database systems that can give you information about the databases, and you can query them as if they are any other table. They might actually be physical tables stored in a database, or they might take some other kind of system information but present it to you as selectable data. So let me switch over here and go to the documentation one. Okay. How's the text size on that? Is that readable?
It's perfect.
Okay. All right. I'm going to go into the trusty AdventureWorks database, and I'm going to start with basically the preferred, the more accepted way of querying system data. Microsoft, back around SQL Server 2005, introduced this SYS schema, and it's meant to augment and replace some of the other system views and system tables that they used to maintain prior to that version, because this way they have a lot more flexibility compared to having to maintain backwards compatibility with the older views. So I'll start with, I'm going to look for my primary key and unique constraints. There is a sys.keyConstraints view here, and I'm going to join that to the tables view, and I basically want to get the object ID of the table and compare it to the parent object that's associated with these constraints here. And this is going to give me a list of, here's the table name, as you can see. Here's the name of the constraint, and most of them are pretty, there's a consistent naming that they used here where it tells you it's a PK underscore, but this is the actual name of the constraint. So it's an object similar to a table in that it has some kind of object identity in the system. And then over here, they'll give you the type. And if I scroll down a little bit, sorry about that, you can see that not only are there primary keys, but they also list unique constraints here. And in this case, the production document table has two different unique constraints. There is a view that would tell me which columns they're marking as unique. I don't know if I have it in this particular script, but there's like a syskey constraint columns that you could join, and then you could figure out which columns are involved with these constraints here. And I don't know if you have a way of making the material available to attendees, Steve, as far as the demos and stuff go.
Sure, absolutely. Either you have your own GitHub, your own website, or I can take stuff from you and put it in our DDT public repo on GitHub.
I do have a GitHub. I haven't put anything up yet for things. I'll probably just zip this up and send it to you.
Okay, sure.
Probably be easier. Okay. All right. So we've determined that here are it's a little bit of information, but at least tells us that, hey, you do have tables. They do have primary keys on them. So AdventureWorks is pretty good in this regard. I've seen much worse, especially from very multi-million-dollar vendors and stuff who don't know how to do a primary key or anything. The next, this would be at the entity and the domain level. This is just telling me about check constraints. And this is, again, sys.check constraints, again, joining to the table. So I can look at the human resources employee, and we have a constraint on the birth date column, pretty nicely named and all that, so pretty good naming scheme. And I can also find out the definition of the constraint. This is basically the logical, hold on one second, I gotta sneeze. Let me just mute so I don't blow your eardrums out. I'll be right back. Sorry about that. Okay, I'm back. Anyhow, birth date. And as you can see, they have a condition here. You have to be born after 1930 or January 1st, 1930. And you have to be at least 18 years old to work there. So that's good to know. A couple other constraints, and I'll come back to some of these later. Gender, you have to be male or female. Let's see. You have to be hired after July 1st, 1996. So that sounds like when the company was first incorporated, that's when the first person was hired and so on. every time you go and change some data or insert new data into the employee table, all of these conditions are going to be evaluated on the data that's being supplied. And if they don't meet these criteria, then you'll get an error, and it'll tell you that the name of this particular constraint was violated. The conditions were violated. So that would represent anything that violates these conditions here would represent invalid data as defined on that table. And it would not be allowed. Or if you tried to update someone's birth date to the wrong value. So this is basically checking not just the type of data. The data types are already doing that. This is checking the values within those data types in those columns that you've set up. So let me go to the next. This is again, this is a domain constraint where we apply a default value for columns, assuming that we don't supply a value when we go to create when we insert the data. So these would only be applied. I don't remember if you can do an update and set it to the default value. I think you can. And these would be, let's see, employee pay history. I guess this isn't ordered the way I thought it would be. All right. So as you can see, there's, let's look at salesperson. So their bonus is defaulted to 0 because they really don't like their salespeople. I guess they have to work for their bonuses or something like that. Their commission percent also defaulted to 0. So being a salesperson at AdventureWorks is not particularly lucrative, but these are sensible defaults. You know, if they don't,
well, it could have been negative. So
actually, it can't. I don't know if it showed up in the previous results. They do have a constraint on
the check on the negative. Okay.
On the commission percentage, yes, but there's another problem with it. I do have a demo for that because it's actually kind of funny.
Okay.
I many years ago had to work on a sales commission database, and whereas before then I didn't really like salespeople that much, I really hate them now. After seeing what they got paid and how little they did to get paid that much. So
Rob, there is a question. What is the resource impact of inserts and updates, actually inserts or updates with those constraints?
I will say this. It's minimal now with today's hardware and the level of performance that we have available. I used to actually, in the older version of this presentation, discuss that even if there was a performance impact, negative performance impact on enforcing a constraint, the time, if you were to put in bad data, if you took the constraint out and then you had bad data in there, the time it would take to find it and fix it and verify that was fixed will dwarf. And I'm talking by millions of times. Even 20 years ago, enforcing a constraint would be a few milliseconds. It will take you hours to find the data that's bad. Assuming you even have a well-indexed, well-performing database that you have full access to and you can query to your heart's desire. It'll take you far longer to find that data, and then you have to determine how to fix it or if you can fix it, because when we get into things with, like, say, data warehousing and all that, where data has to move downstream and be changed and all that, and this is my personal experience, is literally, I would say even years of my life wasted fixing bad data because constraints were not in place. I have a section that's kind of war stories and stuff, so if we have enough time, I might go into that a little bit. I don't want to take too much with that because I'll just turn into a foaming werewolf, basically. But it's amazing. Some of this stuff is, it's really easy to do this and fix this and add this stuff ahead of time, and it will save you so much time later. The only thing I could do is, if you remember the picture of me from before, and just say, hey, without constraints, you'll look like this, okay? And then if I had the nicer picture that Steve had before, with constraints, you'll look like that. Thank you for that suggestion, whoever just made that, because I got to put that into my slides for Summit. But that the quick answer to that is the overhead is really, you'd really have to, you might be able to measure it over, say, 1 million rows of data, but anything less than that, again, on today's hardware, the impact is minuscule. It will be really difficult to measure. And I do have demos of where constraints can improve performance. And that's something that I don't think a lot of people are aware of. So hopefully we'll be able to demo some of those at least and show you certain kinds of queries can benefit from having constraints in place. I'll do this one real quick. So we talked about foreign keys, where two tables have some relationship where a parent or referenced table has to supply valid data to a child or referencing table. And this particular view here, foreign keys, has two columns. One is the parent object ID, and that's where I'm going to join to this table first. And then the referenced object ID, which is the child table. And by joining those two, I can then show you the human resources employee table has a foreign key that references the person.person table. Let me just move this column over here real quick so you can see. So this is essentially, here's the child table, and then here's the parent table. And if you want, I can move it over here. So parent, person.person is referenced by human resources.employee. The department is human resources.department is referenced by employee department history. And as you can see, this probably makes some sense here. I have this employee department history. I got to make sure I'm referencing a correct department. I'm referencing the correct employee, the shift. I guess there's a table of shifts and all that. But this is a rather sensible relationship. You could probably make this is something you would probably design and figure out if you were modeling this kind of data. Employee pay history would have to reference a valid employee and so on. So this is an easy little query to put together. And this next one I borrowed from Stack Overflow, a gentleman named Gustavo, and I think the link is in there. Yeah. If you wanted to take a look at this, I think this is it, or I might have made very minor changes to it. But this will give you all of the columns for the foreign keys. And as you can see, there's a foreign key columns view. Excuse me. I had a hiccup there. And you have to do a couple of joins here. It looks a little complicated, but what it'll tell you is the foreign keys, the names of the foreign key constraints, but it also tells you the table here. So this is, again, the child table, employee pay history, and it's referencing the employee table. And the two columns involved are the business entity ID columns. So in the case of where the column might be a different name in one table or the other, you'd be able to make that determination using this query here. And in essence, any diagramming tool that you would use would write a query very much like this, because it would need to get the names of the tables involved, the names of the columns, and then it would basically just draw a line on a diagram between these two. You'd see human resources pay history with business entity, and there would be a line to the other table there. And having these kinds of columns, if you did have to document this for some reason, if there's an audit of some kind, these kinds of queries would be able to, you could run these very quickly, and then you could just dump this data out into an Excel sheet if someone wanted it for some reason. They could then go and analyze it any way they wanted to. And I think this will show, it'll look like it's duplicated if there are multiple columns in a foreign key constraint, which is valid, by the way, if you wanted to have a combination of columns, as long as they're unique in that parent table that you're referencing, that's being referenced, I mean, and then you just have, again, the same combination of columns in the child table that's referencing them. Okay. So these SYS views are the recommended way of getting this kind of metadata. The older way of doing things, if you were using SQL Server before SQL Server 2005, are defined in the SQL standard under the information underscore schema. This is basically a separate username or schema name, and then the views within this are defined with a particular structure. So information.schema columns, if they have it in a database product like Postgres or Microsoft SQL Server or Oracle, they would have the same structure. And this particular query is basically telling me, here's the name of the table, here's the list of all the columns and their data types, whether they're nullable or not. And if they have a default value, you can see that default value in this list here. There's a number of other columns that I excluded. If you did like select asterisk, you'd get more information from this. There's about, I think, 30 or so columns. So this will give you pretty much all of the information you'd want to know about the column level information within a table. I'm going to cover one or two more really quick, and then get back to a thing. Oh, let me show this one. They do have an information schema for referential constraints, and this is actually gives you very much the same information we got on the foreign key table from before. The terminology is a little different. So constraint catalog, this is the name of the database. So this is the name of the schema, and then this is the name of the foreign key constraint, as you can see. Then I look at the unique constraint database, and then this would be the table. This is the name of the unique constraint on the parent table that the child table would be referencing. It would basically say, hey, I'm going to look in this primary key constraint, and that would actually tell me which data is valid. It then gives you a little more info on if there's cascading actions or other foreign key actions. Let's see. So we do have a cascade down here on sales order header. And this is a feature of foreign keys where if you make a change to data in a parent table that would affect the child table, you have a few options there where you could disallow that change. That would be called, that would be the no action. So if I tried to update a sales order ID, it would not allow me to update a sales order ID. If I deleted a sales order ID, then that deletion, it would go into the child table and then delete all of the rows that had the same sales order ID that I deleted. But I would not be allowed to update a sales order ID to a different value. That would fail. Again, here's select asterisk from, here's all the additional columns here. So I get a little bit more like, which is the first column, second, third. A couple other things. If I have character data, it would tell me how long, for instance, so an nvarchar 50, I wouldn't be able to store more than 50 characters there. A couple more. Let's see. I assume no one's working on SQL Server 2000 or earlier, but if you were, you would probably need to use these SP_help. They are kind of useful. I'll just run this one for sales order detail. It's a stored procedure, and this one in particular, it will detect what kind of object you're querying, and then it will give you multiple result sets that are relevant to that type. So it would tell you here, sales order detail is a table. It's listing a DBO as the owner, which is not correct. So that's another reason we probably want to use the newer versions, is because there's some bugs in here. So it tells you information about that object, and now here it's columns because it's a table. It'll tell you the column information, and it's very much like what we saw in the information schema. And it'll give you a little bit more. If there's an identity column, it will tell you that. A row GUID column gives you information on file groups, if you have multiple file groups. tells you indexes on the table. This is very nice to have. It's not related to constraints, but there is a section later on where it will list the constraints and give you some information about them. Say, for instance, we saw cascade delete on the foreign key there. And sorry, bear with me. And if I look here, it will actually give me some of the definitions that we saw earlier. You can see these check constraints with the conditions that they had that we got from the other system view, the values for the defaults for these default constraints, and some information on the foreign key here. So it can be helpful. It can be a useful thing to get. So sometimes if you have to do specific documentation, you can probably use SP_help.
Rob, I think it was showing DBO because DBO is an owner, but it wasn't showing the schema as DBO.
Well, the thing is, it's owned by the schema. Oh, you know what? You might. I still think it's a bug.
Would be.
Well, when this was written, they did not have schemas per se. They only had users. It's from the Sybase, the days of Sybase, and they added schemas in 2005.
Yep, schemas
that worked properly.
That could be owned. That the schema name.
Yeah.
I mean, potentially the schema name will not match the owner.
Yeah. Well, I'm kind of wondering if the sales schema was set up and it was said authorization DBO, then it might be interpreting that correctly. But I have a feeling that's just a bug. It's probably hard coded to DBO somewhere.
Got it. Quick question for you that is slightly off topic, but inside MSDB, since you're mentioning schema and a table, and you also specifically mentioned the C schema.
Right.
Actually, maybe you're going to be talking about it, but I have a hard time remembering, let's say that it's a DBO.sys jobs.
Oh, yes, I know what you mean. And for those wondering what Steve's asking about, MSDB is a system database, and it has a lot of nice features added, maintaining things like jobs, schedules, and so on. I don't know if I have any jobs. I do have the one job here. Basically, the stuff that you see in this is an Express instance, so it doesn't use SQL Agent. But like if I was scheduling a job of some kind in SQL Agent, you would see when you expand jobs, you would be able to see the information that's in this table here. So this is not a schema name. It's just called sysjobs. And it's actually under the DBO schema.
Any good way to be able to differentiate and remember where you use DBO, where you use sys?
What you can do is this sys dot schemas. Okay, so this will give you the schema ID. Sorry for diverging from constraints. I'll be back in a second. But you can see here the schema ID. You would see this in things like sys tables and the other sys and sys.objects and all that. So if I do sys.objects, so the schema ID would be listed there, and then I could just say DBO is schema ID 1. So I would just say I don't want anything. Actually, let me do the stuff that's equal to 1. So these would be all of the objects that are listed under the DBO schema. You can see the type of object here. So some are user tables and so on. If I and just do type equals U order by name. So I can get a list now of all of the tables that are under the DBO schema. And if I scroll down a little bit more, we see the sys jobs. So sys, the SYS is actually part of the name rather than the particular schema. In this, you can think of it as a container. It's like this particular basket is under SYS, and that's where we put all of these system tables. So this is a holdover from, again, when this was the
1000.
Sybase, yeah, Sybase originated the product for SQL Server. They started a partnership with Microsoft. It was so successful that Microsoft stole the name from them. It's a very interesting story, and you can probably find it online. And Sybase was stuck having to rename their own product something else. And honestly, I don't even know that Sybase is still making a relational database product. I think they've moved on to other things. But yeah, that was...
I think they're part of SAP now.
They probably are. Yeah, they exited that. They were losing a big chunk of market share. But this was basically before Microsoft was Microsoft as we know it today. And then
so that C that's part of the name was probably before they introduced schema name.
Yeah.
Got it.
Oh, and then in this case, there are no objects that are user tables outside of SYS. So let me run this. It looks like these are all functions, basically. So, oh, I didn't know that function. That's pretty cool, actually. Okay. In any case, this is one way of identifying if you're not sure about something, you can figure out. Let me do it this way. There's another way of doing this. You can also use a function called schema name, and you can put the schema ID in there in case you don't want to do a join, and then I can say equals DBO.
I didn't know that schema name function exists.
There's a schema name, and there's also a reciprocal schema ID. So if I knew what, so what I could do is say schema ID DBO, and then I can just say where schema. Let me just take the schema name out. So I could do it that way as well. And there's a lot of functions like that. They'll object name. There's an object name one. So if I wanted the object name of this object ID, I can just object, there we go, name, and then say object ID. And you'll see the name show up twice. So
got it. So you're saying look through sysobjects, find the schema. Okay.
Sys.schemas will list all of the schemas in the database. This would be, for me, I would say start with this. Here's the thing, though. Most of them are system schemas. So DBO, guest, information schema, these are all the same in every single database. MSDB has a couple different ones because they have these SQL agent roles. When you get down a little further, you'll also see these built-in roles here, DB owner, DB access. These are also all the same within every SQL Server database. If I go to master, let me go to master real quick. And so this is, yeah, everything that you see in master here will appear in every single database in SQL Server. And if I go to AdventureWorks, you'll start to see human resources person, sales, and so on. So this is probably the quickest way to start getting a list of schemas. You can also just go to each database, and under the security tab, you'll see a list of schemas here. And this is basically the query it would run to give you this list here.
Got it. Thank you.
All right. So let me switch back to my slides here. I probably have a few more in the demos of queries you can run. I used to go into this a bit more detail, so I don't want to. I don't want to take too much time on that. But there's the queries that if they upload them and all that, they're fairly easy to modify, and they're very, very well documented on the Microsoft documentation, whatever they call it these days. I'll mention this. I don't have a demo for this, but as you saw, we had some functions where I could get information like the name of a schema based on its ID and so on. And one particular function that might be useful for documenting or querying the system views is this object property EX. The EX means it's extended from the original object property function, which I think has been deprecated. It's still there, but there are a couple of things that you can put into it that the older function does not, this particular version. And the first part that I wanted to point out was you can see these property names here. These are parameters that you would pass into this function. You would basically pass in an object ID, and then which of these properties do you want to get? And there's a number here that will actually work on constraints. And it would give you some useful information. If, for instance, I have a constraint, we saw in the system view if they had delete or update cascades, so you could use this in the object property EX function and determine if they have these settings here. This was probably more useful back when, before SQL Server 2005, this function would be an easier way to query that data. Now I can just query, say, sys.constraints, check constraints or foreign keys, and then I'd be able to get the similar information here. But this way might be, depending on how you write your scripts and your documentation, this might be an easier way to get some of that information. You can also do some logical tests. Is this a check constraint? Is this object a constraint of any kind? If it's a default, default object, I might be able to demo that later. If something's a default constraint, it just gives you yes or no. And then later on, you can also check to see, hey, does this table have a check constraint of any kind? So this might be a slightly easier way of querying that. If there's multiple constraints of each kind and you only want one row, you could use this function rather than joining to a one of the other system views. And my guess is if we looked at the, I know I did check this. If you look at the query plan behind some of these function usage, it'll start querying the system tables. And it will look very much like if you were querying the system views. Sorry, I'll go on mute for 1 second. I'll be right back. Excuse me. All right. Let's see. Table is unique constraint and so on. This might be, again, it's an option that you have available. I might have a demo of one of these somewhere. I'll check that when we get to. Oh, demo number 2. So I talked about earlier that there are some performance benefits to proper use of constraints. I think I've demoed some data model documentation, but I'll probably do a little bit more. And also, there's a debate amongst developers and architects about where to put business rules. And my experience is that a lot of business rules will relate to data, and they can be represented as data rules through proper data modeling, design, and application of constraints, and the other kinds of things that we talk about, like don't use varchar max for a zip code, that kind of thing. That's part of correct data typing in data modeling. And the examples I did want to highlight, though, was that they not only showed you the rules of the data per se, they also gave you insight into how the business actually operates. It's kind of a coincidence, but it's something that you might want to think about if you are going to be designing a new system. Let me just see. I'll come back to that in a moment. So let me go into a few of these here. This was not a performance thing, but I'll come back to that one. So I do want to address performance, because I did mention that if you use constraints correctly, you can help enhance the performance of your SQL Server, because having these logical conditions evaluated by the database engine can help it particularly short circuit or take some other kind of optimization path that it would not be able to take if the constraint was not there. what I'm going to do is I'm going to create a table that's declared not null and put some data in it. And then when I get to a situation where I have to query a table, I'm going to turn on the execution plan, and I'm hoping this will scale correctly. Now I'm going to select from this table, and I'm looking for values where that column is null. Now, of course, since it's declared not null and I haven't put any nulls in there, it's not going to return any data. But when I go and look at the query plan, I find that it's doing this particular operation known as a constant scan. And let me see if that shows up there. So that should be, hopefully you can see that. This constant scan is not actually, well, it says it's doing an output list from the column in that table, but it's not actually accessing the table. And the reason it can do that is it understands that there's a constraint, even though it's really a column declaration that says, I can't allow any null values in this table. So it knows it doesn't have to scan that table, and it does this constant scan. This constant scan is basically a synonym for I'm not doing any work. It doesn't have to do any work. There's no work to be done here. And if I do the opposite, the complementary thing where I say where the column is not null, I now get some data back. And when I look at the query plan here, and hopefully this will scale okay, you can see it's actually performing a table scan on that. Let me that up a little bit, a little more info there. There's a little bit more cost. It's still pretty fast, but a constant scan is going to be faster than pretty much any other operation because it's just not doing any work. And if the properties come up here, I'm not sure the hover will work here. Okay. But you can see now you get a little more detail on what this operation actually did, and you can see that there's actual rows that were being returned and accessed and so on. And you see the object, there's an object listed down there, and the output list is the same column in the output list, but the constant scan did not have an object listed at all because, again, there was no work to be done. Because there was, according to that constraint, according to this definition, there could not be any data that met this condition. And I'll probably return to this in a little bit about null. It's important to understand what null is supposed to represent in a relational system. And it's pretty much what's considered an unknown value. I can't compare a null. I can't compare two nulls for equivalence. The example I usually use is that if I know, if I'm in a room with 3 or 4 people, if I don't know any of their names, it doesn't mean that I can assume that they all have the same name. I can't assume anyone shares the same first name, the same last name, because I just don't know them. I haven't been introduced yet. Once I'm introduced to all of them and then I know their names, now I can say, hey, are their names comparable? Are their ages comparable? And when I do this this particular query, I'm sorry, this scrolled off the screen here. In this case, I'm trying to compare this sum column to equal a null or not equal a null. And as you can see here, I don't get any data. And in this case, again, you'll see there's a constant scan for both. The idea is that the column, first of all, is declared as not null. So there would not be a null value in there any place, but also because instead of testing for this condition, this missing value, I'm trying to compare it to a value that just happens to be null. They can't be compared in that way. It's not just a theoretical perspective. When you have a null value, there is no data type associated with it. Again, because it's from the theoretical side, it's unknown. How do you know if it's a number? How do you know if it's a date? One other example I used to mention was if someone's weight and someone's height and someone's age, those can all be represented as numbers, but those particular attributes are actually not comparable to each other anyway, even though they're numbers, because age, weight, and height are measuring completely different things, different dimensions in that respect. And in this case, for like weight and height, they're actually physical dimensions. Age is also a physical dimension. And this property extends not just to an expression here, but also to an actual variable. So if I was to get a value from somewhere and it was marked as a null, even though it's typed as an integer, okay, I still can't make a comparison. I won't get any data from this comparison. As you can see, though, in the first case, I'm doing an equivalence to say, hey, is this equal to null? It is actually doing a table scan. Even though the value is null, because if this value was not null, it would be able to do a comparison there. So it's still doing the data access to determine if there's a value, but because it's null, it's not going to find anything. Then when I get to the not equals to null, oh, this is supposed to be not equal to var. Let me save that change here. Let me do this again. It's just going to do table scan. And now again, this particular variable may or may not be null. It has to access the table in order to determine whether they match or not. But again, the comparison itself to a null value still returns no rows. They're not equivalent, even if it's the correct data. In this case, a null is declared as an integer. It's the correct data type, but it's still not a value that can be compared. And let me go to AdventureWorks. Let's see. Oh, and I think I mentioned this again, since the column sales order detail, the sales order ID column is declared as not null, and I get a constant scan here. I do remember what I wanted to do with this demo. I don't think it's in the right place. Let me... I'm going to skip this demo. I'll mention what I intended to do with this one. I'm making some changes to the data in this table because I wanted to mention a particular pattern that you might want to reconsider using. In this case, I'm trying to find a sales order ID that's in the sales order header that does not exist. Basically, I want to find any sales orders that have no line items associated with them. And generally, most people would use a left join to the child table, and then they would have a where clause that says this column would be null. In this instance, the left join, in not finding a match, so that would be the orphaned row, it would return a null for these columns in here. From a logical perspective, since sales order detail doesn't allow nulls in this column, this really should not return any data. Even if the row is missing, it should not return anything because sales order detail can't allow nulls in there. And generally, the more logical way to approach this is to say, I want to look for sales order detail, and I want to say not exists. I want to look for I want to find rows where the sales order detail, the sales order ID doesn't match in the sales order detail table. So I apologize. I should probably rearrange these demos for that one. Let me go back to. Let me do one or two more performance ones. So we looked at how if I declare a column not null, instances where I might check for a null value can be short-circuited into this constant scan operation, which returns immediately and does less work. Let me go to performance check. So there's a not null declaration on a column. I'm going to look at a check constraint now, and I'm going to set this up where I'm going to ensure that the value of the column A is between 7 and 10. So I'll create the column, create the table, put some data in there, and now I'm going to turn on the query plan again. And now I'm going to run a query. I'm going to look for anything from the table where A is less than or equal to 1. So I don't get any data because there isn't any. And again, I get a constant scan. Let me move this up a little bit. So I can scroll. Hopefully you can see it. So again, constant scan means it's not doing any work. It's not doing any physical access. Because it can see this condition, and then it can see, do I have any constraints that might affect this condition? And I do. And it says, hey, it's got to be between 7 and 10. This value is outside of the allowable range, so it will not return any data. And I'll do one here where, hey, A is less than 10. And I now get data. And you hopefully can see the operator. Do I need to zoom these, or are you able to make out that it's a table scan and a constant scan without zooming?
No, I can clearly see it. It's big enough.
Okay, it's big enough now. All right.
Yep.
All right. So again, now it's scanning the table because it did find data. So it's going to have to do that in order to return any data. And if I say if it's equal to 10, so now it didn't return any data because I don't have anything equal to 10. And it did do a table scan as well, because this is within the realm of the constraint. This value is possible within that table based on the constraint. The next one, greater than 10, returns no data and is again a constant scan. It's outside of the allowable range of the check constraint. So now, if you define some kind of logical condition and your data is validated in it once it's inserted, this query optimizer is basically saying, I don't have to do any work here because the data can't possibly exist in this table the way this query is written. And if I go down to these last two, I think I just want to run them. I think, again, they don't return data because there's no values that match them. One is less than 7, the other is greater than 9. First one's a constant scan because it's outside the range, and then 9 is within the range, but the table scan returns no rows. I think it would tell you actual number of rows is 0. All right. So this is, I think someone was asking about the impact of the performance impact of having the constraint. So I spend a few milliseconds validating that these values are in the correct range. If this was a billion row table and I'm looking for values that can't exist because the constraint has been determined, what do you think is going to be faster, scanning a billion row table and not finding any data versus I don't have to scan, I have a logical constraint that's been enforced on this table, so I don't have to scan it? Which do you think is going to be faster, and which would you prefer to have? Is, something that's maybe a millisecond fast to insert and update versus not having to scan millions, billions of rows or however many you have?
I think it's obvious.
Yeah. All right, let me go to AdventureWorks. And there's a metadata attribute associated with constraints to tell you, let me turn off the query plan here. There's two that are associated with check constraints and foreign key constraints. One is called disabled, and you'll see that it is disabled. And another one is called is not trusted, which is the inverted logic. A trusted constraint is a constraint that had been disabled at one point and then re-enabled. However, the data that's inside the table has not been validated since the constraint has been re-enabled. It's mostly for documentation purposes. The problem with it, and I think I have a demo for this. I hope I have time for it. Steve, how much time do we have?
You have all the time.
Okay, I don't want to take too long because I know people have like families and stuff because I heard them on the thing here. So I don't want to keep people too late. But the idea is that if I disable a constraint, can I disable it? Yeah, give me a second here. By the way, I do this where check constraint. Oh, okay. Yeah, I name tables with just a single £sign because I'm weird like that. Okay. So as
I saw your presentation.
Okay. What I'm doing here is I'm altering this table. I'm just saying set these constraints to no check. Now when I run this, now I still get no data, And I need to turn the query plan back on. This again. Because the constraint is disabled, it's not being checked right now. I could insert some data in there. In fact, I'm going to insert 19 or 99. There you go. So I'm going to insert some data in there. And there's no violation here. So even though this constraint is listed as between 7 and 10, I just inserted 99. And then when I query less than that, even though it's outside the range of the constraint, it still has to scan the table now. It's not being enforced. And then what I can do is check constraint all. So I'll run that. So now it re-enabled the constraint. However, it's still scanning the whole table, even though data's there. And I totally did this out of sequence. What I'm now doing is I'm going to alter the table and I'm going to say, hey, go and check all of the data on all of the constraints. And I should get an error when I try to do that. And this failed because it might even tell me, it won't tell me. I'd have to delete the 99 from that. Oh, hey, greater than 10. Okay, so one row got deleted. And now when I apply, the data is now all valid. And now when I try to find this out of range, I get the constant scan like I did before. Okay, so I totally preempted another demo I was going to do on that. Oops. And I think, again, in a different context, if I were to disable these constraints here, then you would see both of these two columns would say they're as 1. If I re-enable it, disabled would go to 0, but is not trusted would still be 1. I would have to then alter them and use this with check clause here. It's a little confusing because you're saying alter table with check constraint, but it's insisting that I need you to go and actually check all of the data. Don't just turn it back on with this check. Actually go and read all of the data as you enable the constraint. Okay. Any questions on that? Makes sense. I think. Yeah, I meant to check these execution plans. Because there were constraints on human resources regarding, these gender columns and stuff like that. Apparently, though, and I wasn't sure why, they're still doing scans of the, in this case, there's a clustered index that they're accessing. So even though there's constraints that would, as you can see, the gender is either F or M, I'm putting in a capital Z, where I'm saying it's equivalent, I'm putting it in an in clause, I'm applying the upper function to this. It's still scanning the table, even though the constraint would prevent that kind of data from going in there. And I hadn't quite figured out why that example was like that. I think I know why now, but I'd have to confirm it. We also have one on hire date. And again, no data. It's still accessing the table, so even though there's a constraint in place and it's being enforced, for some reason it's still scanning the table rather than short-circuiting with the constant scan. And I think this one also is scanning the table. Okay. But as you saw, if I have the constraint assigned correctly, if it finds a condition that it knows can't exist in the table, it can optimize it down to basically 0 work. And that's a big performance improvement. This is especially nice if you have tables that have multi-millions of rows that you're joining to other tables with multi-millions of rows, and there's a nice check constraint that can make that a little bit faster. And if you want, I can give you a really good demo on that one. Yeah, let me show you this one, because this is a very neat little feature. And this is available in every version of SQL Server, every edition. So you can do this in Enterprise Edition. There's a feature known as a partitioned view. What it allows you to do is set up tables that have similar data, but they only have a subset of that data. So in this case, I'm going to take the sales data for the year 2013, so all these dates here, and I'm going to stick them into a separate table. And I'm going to do that for the years 2011, 2012, and 2013. And they're created. I'm now going to query sales order header and grab all of the relevant data for each table and insert it. Okay. And as you can see, there's a check constraint. Order date has to be between these values. So none of these inserts violated that. And now, sorry, I got a trackpad here. It's slick. I'm going to create this view because I want to basically combine all of these different years of sales into one view. So if I want to get all of the sales data, I can just query this one object. I'm going to select from each table, and I'm going to union all of their results together. And run that. And now when I query sales partitioned view, I'm going to get data for all of the sales years. So you see 2012, 2011, 2013, everything's combined. Let's say, though, I only want to look at orders from, let me turn on show plan. So when I query this view, and hopefully this will be a little more visible. If I need to zoom this plan, let me know. If you look, you can make out that it's actually scanning all three tables, 2011, 2012, and 2013. This concatenation operation is basically the union all operation. So all the rows from one are then appended to the other and so on, and then they're all returned in a single select statement. And I think it tells you the total number of rows somewhere. So now I'm going to query this, but I'm going to have a condition where I only want orders from January 1st, 2013 onwards. So I don't get the same number of rows. I only get the relevant data. But when I look at the query plan, it doesn't even query the years for 2011 and 2012. Because again, we have a check constraint on the individual tables that restricts that. So it knows, hey, I'm not going to find any 2013 data in here, so it doesn't bother querying it. And that's why it's absent from the plan. It's not quite a constant scan. It's just eliminated those tables as not being relevant. This is also known as partition elimination. If you've done table partitioning in SQL Server, you might have heard that term partition elimination. And a partition function on a partition table would have a similar condition. It would basically say, here's a range of values that's valid for this partition. So I'm going to drop the constraints on 2012 and 2013. I'm going to run the same query again, where it's going to look at order dates from 2013 onwards. And now you can see that there's two table scans, one for 2013 because that's the relevant table. The other is for 2012 because there's no constraint indicating whether there's data or not. I didn't drop the constraint from the 2011 table, so it has been eliminated here. It doesn't need to be scanned. And hopefully you can see that when I hover over the rows returned from this one, it actually shows as 0. It read 3,900 rows, but didn't actually return any because they don't match the condition. And then on this one, it returned, didn't return all of the rows, but it did return data from that one. And then what I have to do is I have to go and add the constraint back in, and it passed. And then we get the same partition elimination now that the constraints are there. It's only looking at the 2013 table. And now If you were here in person, I'd ask you, hey, what would happen if I ran this query? But I'll tell you, I get no data and I get a constant scan because that date is completely out of the range of all of the tables. So it just does no work. So these constant scans are really, really nice things. You want to have constant scans in your query plans as much as possible. They make them a lot smaller and return no data, but very, very quickly. And again, I mentioned earlier, partitioning, it's available now, I think in SQL Server 2016 and onward, where you can actually partition tables in all editions. But partitioned views are supported, they actually are supported back to at least SQL Server 2000. They might even be supported in SQL Server 7.0 if you're still using that. But you can get this kind of performance improvement from the optimizer by having constraints on your tables. And again, these are smaller, a few thousand rows worth of data. But if you had billions of rows in these tables and you had to union them together in a view, being able to eliminate having to scan something that large would be a huge performance improvement. All right, let me go back to slides here. Does anyone want to see more on performance improvements? Oh, I did that one already. Okay. I'm going to skip that one. All right. Let me go data model documentation. Yeah, that here. I don't think I did. I'll come back to that one. And as I said, I was restructuring this presentation, so some of my scripts are they're not in the order I had expected. So I apologize for that. So I'll find it. I know it's here someplace. Data model documentation. Go back to you. Yeah, discover constraints. Yeah, bear with me. Let me just query AdventureWorks again and check constraints. So from looking at a data model documentation, whereas I can get the structures of tables, the data types of the columns, defaults and check constraints and stuff, the data model documentation and the business rules documentation in this particular example has some overlap here. This isn't just telling me the birth date and the definition of the constraint on the birth date. If I look a little more deeply into this, AdventureWorks as a company has a policy of not hiring anyone under the age of 18. If I tried to put in a birth year that says someone's 17 years old, this constraint would fail. I may or may not be able to joke about the gender here because this is a more recent phenomenon of non-binary genders as far as females and males. So this is the case where AdventureWorks is a bit behind the times, that their employees would possibly have a potential lawsuit against them from the perspective of this database. And it's not to make light of that. It's just to point out that this is restricting what would be potentially other values that would be valid. For instance, marital status, upper S or upper M, so it's either single or married. If for some reason they needed to indicate someone was divorced, they would not be able to put a divorced person in here. I can also look a little further down and see, hey, here's their sick leave policy. You can have up to 120 hours of sick leave at this company. So this is actually an employment condition. It's not just a data condition. You can carry, it looks like you can carry over up to 40 hours of vacation. That's my interpretation here. And you can have up to 240 hours of paid vacation. Um, this is actually telling me how their employment works, because this is in the employee table. You can make this kind of a deduction based on the name of the table and the conditions that you find on the columns and how they're being done. And if you were a consultant or contractor or someone starting in a new company, and you wanted to find out information about business rules, all of that stuff that, again, most developers say you put the business rules in the application code, it would take you forever to derive this kind of information from the code itself. And probably be a lot harder to find, even if it was documented in some document that was either indexed or cross-referenced or some way that makes it easier for them to say, hey, what's your sick leave policy? Well, it's right here, and I can query it like any other table, and it tells me I can derive some of this policy information from these values here. So that's why when this conversation of where to put business rules and stuff like that, I find these two things, data modeling, documentation of the model and the business rules, you can have a lot of confluence between the two if you apply constraints to the database rather than hiding it in an application somewhere or documentation. I have to honestly say the last couple of jobs I've been at, there's really been no actual documentation of anything. There might be some tickets in some source control or ticketing system, and they'll talk about a problem or something like that or a bug, and they'll fix it. But that's sometimes the only place you can find any kind of structured information about what these systems are supposed to do. And it's really incomplete. This is something that may not be complete, but it's helpful. It's probably enough in some cases. My quantities have to be greater than 0 or greater than 1 in some cases, and so on. The prices have to be greater than 0, so you don't accidentally pay a customer to buy your product. You don't want that. You'll go out of business more quickly if you're giving them money in addition to the product that you charge money for. And so this leads me to, we've seen the benefits of this from a performance perspective, a documentation perspective. When you reach a point where you have to start talking about designing a database and a table, some of these questions I think are, they're good to ask. And I wanted to impress, this would be easier in person where we could actually have this conversation. How long would it take you to determine, all right, what's in this table? How many columns does it have? It's got 5 columns. What are the types? And you could talk about, well, first name and last name or character. Date of birth would be a date. What would happen if, what's an invalid date for date of birth? So someone from 1700, yeah, that's too early. 1800, that's too early. 1900, that's someone who would be 120 something years old now. In other words, maybe we should put a range of valid dates on this column. If anyone was old enough to remember Y2K, when they were only storing years as 2 digits, and this was actually happening with banks. They were getting mortgages that were going to mature in like the mid 70s, and they were 30-year mortgages, and they were getting errors on some of these calculations. Other mortgages by the late 90s, almost every mortgage was going to mature in the next century, and every time they did the math, they were getting negative numbers, and the things were failing. So that's something where you apply a little more common sense to things. What would be the consequence of this data being invalid? And in the banking industry, that could lead to some regulatory action. They could be sued. They could lose their license, that kind of thing. Same thing for if something is null. And we've seen some logic where, hey, if I might assume that, hey, if the last name is not equal to Smith, all of the last names that are null should be returned. But you can't make that assumption. So you have to remember how to handle it if you have missing data to ensure whether you should include that missing value or not with the is null thing here. We move on to, once I've created the table, I've got the columns in there. I gotta determine what's the consequence of having duplicate data? And what would constitute a unique name or a unique value or something like that? An example that I had is the Screen Actors Guild. They have a rule that an actor, a member of the guild, cannot have the same name as another guild member. And one of the examples I use is Michael Douglas. So there's basically two Michael Douglases. One of them is Kirk Douglas's son, who played Gordon Gekko and was also in Fatal Attraction. He's the first Michael Douglas. There's another Michael Douglas who is also known as Beetlejuice and Batman, only he's credited as Michael Keaton. So he had to change his name because Michael Douglas became a member of the Screen Actors Guild before he did. So he's now Michael Keaton. And that's basically, they're applying a unique constraint on the name that people are using when they're credited on a movie. What would happen if, the two Michael Douglases were in there? One is, you would imagine the guy who played Gordon Gekko as Beetlejuice and also as Batman, which I think would be very interesting casting now that I mention it. But the other thing is that, if there's royalty checks and other things where they have to interact with the Screen Actors Guild, you're crediting the wrong person. If there's a Hollywood scandal of some kind and the wrong Michael Douglas is associated with that scandal, that could ruin a career. So that's actually a fairly good rule, and it makes sense within the that particular context. Is we don't want to mix up these two different actors.
Rob, don't
Yes.
want to steal your thunder, but this is actually very common in sales. So people even changing or slightly modifying their first name.
Yep.
Just not to miss their commission.
Yeah. And I think I probably had an instance where one of our sales reps got married, and it either wasn't reflected in the commissions, or we sent the report in under her maiden name, and she didn't get paid because her name had been changed in the system and they couldn't find a match. And you talk to any salesperson, if their commission check is delayed by about 4 minutes, they start having panic attacks.
Yeah.
But that kind of thing happens a lot. And that's another thing you have to deal with, is names changing. And I have some links later about certain things, or I have them in some scripts here and all that. So basically, we started with get your columns and your domains straightened out. Figure out if this column by itself, first name, last name, is there anything about it that would be wrong in and of itself? When I get into combinations of columns, first name and last name, where would there start to be a problem? In this case, we can't have two Michael Douglases. We can't have two John Smiths. So that combination would have to be marked as unique somehow. I'd also have to think about, hey, if somehow I got two Michael Douglases in there, how do I identify if I go look at, say, like the IMDb database, okay? And you'll sometimes see names with a 1 or a 2 or a 3 after them. Is this Michael Douglas, was he actually in this? Is this the right Michael Douglas for this movie? How do I correct it if it is wrong? If for some reason Michael Douglas, Kirk Douglas's son, is associated with Beetlejuice, he obviously wasn't in that movie. How do I correct it? Which is the correct Michael Douglas / Michael Keaton to assign to it? So they avoid that problem by just saying, I can't have two of the same names. I have had to deal with this incorrect dupe thing more times than I can count. More times than I think can be counted. This is getting into heavy set theory with uncountable numbers bigger than infinity. It was so prevalent, is just duplicates and stuff. I mentioned earlier about, the men being identified as pregnant. So there's combinations of columns that are not valid. They might still be unique, or they're just not part of that uniqueness condition, but you still have to verify that it's a valid combination. Then we get into relating these tables together. I mentioned Netflix before. I want to have a valid subscriber, and I want to have a valid episode, and then I can decide whether they can watch it or not. In the case of this example I have on the slides here, is I need to create a table to record mortgages. And there's components to a mortgage that are entities that stand alone outside of this actual mortgage. For instance, a property. I have to, hey, what property am I trying to sell here? Am I trying to give someone a loan? I need to define this property, and I'll need to deal with, the local town or whoever manages property taxes, ownership, things like that. And they're going to need certain information. I'm going to need information from them. I need to provide them with information. Hey, is this an actual parcel of land, or is this just a swamp somewhere in Florida? Can you actually build on it? Is it zoned for construction if there's no buildings? If there are buildings on there, are they in a condition for someone to live in? Because it's a swamp in Florida. It may not be. And not to make fun of the hurricane that went through and all that, but this comes up a lot when there's major damages and things like that, is some of these properties may now be rendered uninhabitable. And you might have a mortgage on there, but there's nothing for you to pay on anymore. It has to be canceled. It has to be processed somehow, strictly on the condition of the property. You then get into, okay, who's lending you the money? Are they a bank? What kind of financial institution are they? Are they allowed to write mortgage loans? Because if you lived through 2008, you probably dealt with a few of them that weren't really able to lend money. You also got into lendees, people who were getting these loans and they couldn't pay them back. They may not have been a living person. They might have been, or may not have been, a corporate entity. All the things that I have listed here, basically they were not legally allowed. They should never have gotten a mortgage. Every one of these component tables has its own internal logic we would address with these previous two slides. I'd have to define a property in such a way that it makes sense to everyone else that deals with a property. If I have to get someone to build something on it, install some kind of irrigation or drainage, make sure that it's valid. I'm trying to build something that doesn't violate codes and all that. The lenders have to be licensed and whatever, and so on. And by having these three tables, this becomes an intersection where now I can write a mortgage. I have, here's the property being mortgaged, here's the bank or whatever lending me the money, here's the person getting that loan. That's where your relational constraints with foreign keys and stuff come in.
Rob?
Yes, sir.
Are you planning also to show, so the create new is obviously you creating standards. And over time, as you explained, standards can change. Mm-hmm. So are you planning to show also how to alter the constraints and also what the performance implication could be? Let's say after millions of mortgages, now you need to change one of the constraints that you created. What would be the implication in terms of performance?
I will take that as a note. That will probably show up when I do this at PASS Summit. I don't have a demo for that at this moment. I was sketching this out, and it was just something that I'm like, oh, it's the idea of having an intersection of rows. Say the Netflix queue again is, here's a subscriber, here's a show. The intersection is every time I watch it. Every time I watch it, you'll see me and this show and some kind of timestamp. For a mortgage, it's expanding it a little bit because now there's three elements. And it's, again, one of the nicer things about relational theory is that you can relate these things any way you want. Right now, property, lender, and lendee are unrelated. I create a mortgage table. I put some foreign keys in there, and now this new thing appears. And it's literally an intersection of this property, this lender, this lendee. And it's possible that there could be some piece of land, multiple mortgages are on the same property. They might have sub-parcels or something like that. And I used to deal with some property-related industry with utility billing, and we would have discussions about how to model a property correctly from a utility billing standpoint. So it's similar to this kind of question, and I think it's one of the more I think it's more understandable to some people is that this is a very obvious relationship between different entities. Every one of them can stand on their own. There are bank databases that have information about banks that have nothing to do with mortgages. There are information about properties that have nothing to do with mortgages. everybody is in a database somewhere, definitely Facebook. Everyone has all their information in Facebook, even if you don't have a mortgage. It's again creating this intersection of different data domains to create this new thing, which is a mortgage, and then you can track that mortgage. I would then have ancillary tables on the mortgage. Hey, what's the payment schedule? Did we receive the payment? Did we receive the full payment? Was it more? Was it less? Were there factors that affected their credit rating where we can't, we have to cancel the mortgage? Like, for instance, your bank goes out of business or gets acquired. Was the mortgage done fraudulently? Will the courts have to get involved and vacate the mortgage, which means you may get a house for free? Because that happened a lot in like 2008, 2009. So that's, you can, for me anyway, I think it's just something that I felt was a good example. The relationships are fairly obvious or understandable in this regard. Any questions on this? Any thoughts? Any other feedback you have? And it can be negative feedback. If you think I'm not doing well, I'd appreciate that. If it's not tonight, send it to Steve, and if Steve can forward it, I'd appreciate it.
Sure.
Okay. Because some of this is kind of flying seat of the pants here. I do have some references I want to make to other people. Unfortunately, I can't paste them into the chat. It's not available to me in Teams. So Deborah Milken has done this presentation called Data Integrity Demystified. One of these links is for Past Summit 2020. It's really good. She covers quite a few of the things I talked about in more detail. She has some examples, including some of the performance things that I mentioned as far as doing constant scans and some other optimizations that constraints can make available. So I'd say if you wanted to screenshot this and if you want to look at it before I get the slides uploaded. But this was very good, and it does cover constraints in addition to some other things, as well as some database design stuff that I think would be a good use of your time to follow. And a couple other presentations, two specifically on data types. Andy Yun has one about every byte counts, where he goes into a lot of detail on why you want to store a date as a date compared to a character column. Even if it's only 8 characters, a string will take up more space than a date will. A string will not index correctly if you store the dates the wrong way. So when you try to order it or something like that, they'll come out in the wrong order. Things like that. Angela Henry also goes into a lot of detail on data types, especially from sizes. She has an example where I think she cut something in like half or less than half the size, and it was very, very minor changes to the data types. Let's see. And this one, I didn't finish watching this one, but Edward does a good, he talks about design up front. This gets a lot of bad press now because the agile methodology, hey, let's just throw something out there, see if it sticks. And what I was hoping, I wish I had timed this, is basically how long did we actually spend discussing these 3 slides? Because this is something that you can talk about in about 5 minutes. This 5 minutes can save you months, and I do mean months, of heartache and pain and aggravation. And Edward, he probably addresses it in some way in this presentation. As I said, I haven't finished watching it yet. But this was the gist of when I started this presentation is like, guys, don't be like me. Don't waste your life fixing these stupid data errors. Just put some constraints in there. And they run faster too, I do have like 1 or 2 more scripts I want to get into. I do want to point out, though, that bad data, it's going to be in your system. You're not going to get 100% of it. You're not going to get all of it. And you'll probably not even notice that it's in there. But if you do have some examples, some of these are fairly well known. They're not really database related, but they do have bad data or bad processes associated with them. The first one, the Ariane 5, the first flight of the Ariane 5 rocket. The Ariane 4 was one of the more reliable rocket systems ever built. They took the flight control system and put it into the Ariane 5. That rocket was substantially larger, had a substantially bigger performance envelope, which meant it was faster, it was heavier, it was bigger, and it could handle forces that the other rocket could not handle. They chose the wrong data type for, I think it was the heading or something like that, and a 16-bit integer got incremented to a number that couldn't fit in a 16-bit integer. And for those of you who are C programmers or know how this works, when the bits get when a bit gets flipped at one end, it goes from a positive number to a negative number. And it goes from a positive number of a very high magnitude to a negative number, basically the absolute opposite. And the only way that you could flip that number is basically the rocket is completely out of control. And that's exactly what happened. And this rocket automatically self-destructed because it thought it was out of control, when in fact it was not. It was actually flying okay. It just went a little bit too far to one side, and the self-destruct system said, you're freaking out, I'm going to blow you up. So that's a bad data type there. The Mars Climate Orbiter, one team used metric units, the other team used imperial units, US units, and they didn't do the conversion factor. So I think the metric is something like 4.5 times smaller or something like that. So it thought it was doing 100 miles an hour. It was actually only doing 20 miles an hour or something like that. And it crashed into Mars. So, or vice versa. It was going too fast. I can't remember. So that's probably a bad data type. It was not a consistent design. It was not a consistent data type across basically the same things. They're measuring the same things. They were just using the wrong units. They weren't converting the units correctly. I'll leave the last two. You can look them up. I had more on this slide. And there were some instances I had where bad data and bad process discipline caused people to get killed. So bad data can have some really dramatic consequences, even if it doesn't necessarily affect you. There's plenty of other programming errors, slight minor mistakes where companies went bankrupt within an hour. So that's let me go back one. Let me just see where the other thing here. Let me do this demo real quick. We had the sales commission percent column here. So this is how much money, the percentage of money that the salespeople get. It defaults to 0. So right now, that default is 0. There are no check constraints on the salesperson table. As you can see down here, there's no data returned. And I'm going to go look at commission percentage. And since percentages are decimals, I'm going to just multiply it by 100 to give you the actual percentage here. And as you can see, this commission schedule is pretty bad for AdventureWorks. They don't pay their salespeople. I think the highest one is like less than 2%. 2% sales commission. Now, if you were a salesperson there and you knew a little tiny bit of SQL, you might decide to go in there and give yourself a slight raise, And now your sales commission, instead of being, 2% or 1.2%, it's now 12,000%. Now, this is great for the salespeople. This is really, really bad for AdventureWorks as a company because they're paying these people 120 times as much money as they're earning. So this is not going to last very long. Hopefully that went back to normal. Yes, it did. Okay. And here's the essence of where this problem came in is the data type they chose, small money, They probably chose because it's got 4 decimal places built in, and it's only a 4-byte data type. So it can represent percentages very efficiently compared to, say, a decimal data type, which will be a minimum of 5 bytes. The problem is small money can store what is in essence a 4-byte integer, which goes up to 2 billion, and then they just divide it by, I guess, 10,000 to give you the 4 decimal places, which gives you something like 280,000 as a valid value. And that's what they didn't protect against. They didn't protect against an upper limit of sales commission percent. And that's what this, I'm going to add this constraint here. This constraint says, check that the commission percent is between 0 and something less than 1. Even 99% sales commission is pretty high. But at least it can't do, oops, hold on. Something crazy like this here. Now when I try to do this update, and it tells me it conflicted with the check constraint because the value is now out of range according to the constraint that's there. All right, and I'm just going to drop that here. Okay, so this is one of the examples that I have in another script here. Let's see. Did I put it in here? Ah, I did put it here. Okay. So this is a little more detail about what I just demonstrated. This is where you do have to look at the data type you're storing. Percentages always need to have a decimal representation because you're going to be multiplying percentages by another number. You want to make sure that the math calculates out like you expect it to. You have to worry about things like data types like float and real. So they have they have decimal places built in, however, they are not precise. So if you have to do, if you're summing up a discount or a percentage across millions of rows, there will be rounding errors that will accumulate and you will get the wrong number at the end. So you want to choose not just a data type, but also how it works across individual rows multiplied and so on. You have to be careful about whether a negative is allowed. I could swear there was a constraint on there that said it had to be greater than 0, but there was no upper limit to it. So you need to apply some common sense to some of these. I mentioned this note here about date of birth. I see this as a date time. No one cares the actual minute the baby was born. You just need the date. So just change this into a date. It's 3 bytes instead of 8 bytes. So most of this is going to sound like common sense. It's just that common sense is not common, apparently. So this is, again, based on my experiences. That's why these scripts all say experience. Do you want me to continue with these, or do you think we should finish because we're at...
I think we should finish.
Okay. All right. So I'll upload these. And again, if you had any questions, you can email me. My contact info is there. Again, SQL_R@outlook.com. I don't think I had anything else there. Grants and stuff. So some of these are going, again, they're based on my experiences with bad, lack of constraints and bad stuff. Couple things I want to point out is that link there, and again, I'll upload this slide about the NHS with the pregnant men. There is a book that Redgate publishes down here called Defensive Database Programming. It was written by Alex Kuznetsov, and he has a couple of chapters on constraint usage from a design upfront perspective. Getting ahead of the design before you start committing it to production and getting real production data in there. And he has a couple of articles. One was on using constraints to basically handle the professor scheduling problem, where you want to make sure that you don't have 2 classes in the same room at the same time. You don't have a professor booked during the same time frame for 2 different classes, that kind of thing. And typically that's something you have to write a lot of logic for. He was able to do it using just constraints on a table so that he will never get overlaps and things like that. So there is a lot that it can do that you might think can only be done in the application side, but it can be done in the database. And with that, I will, I'll hold this for a moment if you need to screenshot that, and I'm going to stop sharing. All right. Thank you again.
Thank you for the presentation.
Thank you for having me, and have a good night, everyone. Thank you for attending, and take care.
Thank you for attending. Good night. Bye-bye.